Okay, all right. So today we are onward towards Unit 8, Lesson 4, and now we're going to talk about area of quadrilaterals because in Lesson 3 we talked about triangles. So what's a quadrilateral? Let's talk about that. The word quad, right? So tri means three, right? Hence triangle, quadril, right? Quad, lat, right? So four sides. So any shapes that has four sides, okay? That's called a quadrilateral. Some, of course, are more standard than others, right? And I'm going to show you what those are today. All right, so what is it? It's the study that, okay, all right, not the greatest sentence written here. So today I'm going to show you the four types of quadrilaterals that you need to know, what they look like, what the formula is for the area of these quadrilaterals, and where applicable, I will show you how these formulas originate. Okay, all right, so first of all, what's the area again, right? It's the space inside a shape, whereas a perimeter is the distance around a shape. So for our purpose today, we're going to focus on the area. So here we got four types of quadrilaterals, all right? The first of which should be very familiar to you, right? That's the square. So how do you find the formula? How do you find the area of a square? You take your side, you multiply by another side, and there you have it. So for example, if one side of the area is 3, if one side of the square is 3, what's the area? It would be 3 squared. So what's 3 squared? 9. Okay? Second one, here we have a rectangle, right? The area of a rectangle is length times width. All right? So for example, if the length is 5 and the width is 2, you would get 2 times 5, and that would be 10, right? Third, we have a parallelogram. Now, why is it called a parallelogram? Because both opposite sides and both of them in the shape are parallel to one another. Meaning, should you draw the line continuously, they will never intercept or touch one another. So if you draw this line continuously like so, and draw the bottom, the base, I guess, like so, they'll never touch. So that's the definition of the word parallel. And on the other hand, if you look at this side, the left side and the right side, and you draw two lines going continuously like so, like what I'm doing now, you realize that those two lines also never touch. So a parallelogram has the distinction of having opposite sides that are parallel that never, and having two pairs of them. Now, technically speaking, a rectangle is also actually a parallelogram, right? Because this side and this side, they're parallel, and so are these two sides, the left and the right side. They're also parallel. The widths are parallel, the lengths are parallel. Okay, just so you know. And to find the area of a parallelogram, it's just base times the height here. Okay, so I'll show you more in a second. Let me see if actually, no, I gotta show you now. All right, so I'm gonna use red here. So so I just drew a box here, all right, to denote height. So if the base, right, is 10 and the height is 3 here, then to find the area of a parallelogram, you would just do base, which is 10, times the height, 3, and that will be 30. Now, interestingly, right? The origin of this formula is very much like the rectangle, because a rectangle is just length times width, right? Here, you're just doing base times height. So imagine that a parallelogram is a, It's a rectangle that just got blew by the wind, all right? So let's say the wind was blowing very hard, and it was blowing on a rectangle. The wind will basically knock the rectangle into a parallelogram. Think about it like that, okay? If you can imagine that, then that helps you memorize this a little bit easier. Now, I'm also going to tell you, I don't think these 4 formulas are provided on the state test. I think only the triangle is, okay? I got to double check, but I don't think they are, so you're required or you're supposed to remember these formulas, okay? Just saying. All right. Lastly, here we have a trapezoid. So hold on, I should probably write down the names of these shapes, right? That's a rectangle. That's a parallelogram. Parallelogram. And here we have a trapezoid. All right, so what's a trapezoid? It's kind of like a parallelogram and also a rectangle, except these 2 sides, they're not parallel. Okay, you can look at it like that. So now there's a lot going on in this formula. So I'll break them down for you as much as I could. So I'm going to use the thinnest pen I can get, and let me use a different color. Okay, so here this is base 1. Okay, that did not change anything. All right. So this is base 1. This is base 2. Notice the subscript here, right? The little letter. This is not an exponent. This is a subscript. So it's to tell you that even though these are both bases, this is the first one, this is the second one. All right? So base 1, base 2. This is the height. Let's use red. That's the height. And then this is divided by 2. Okay, so what am I trying to say? In other words, to find the area of a trapezoid, you have to add the base together. So I'll give you an example. Let's use a numeric example. So let me use, let's say that's 4, right? Let's say this is 6 and the height is 3, okay? So I'll use parentheses to help you see a little better. So, let's see. So, what I'm trying to say is, right, 4 plus 6, base 1, 4, base 2, 6, multiplied by the height, which is 3, and then you take this whole thing and divide it by 2. Okay, so what would that look like? Well, let's see. Order of operations, 4 plus 6 is 10. 10 times 3 is 30. Over 2, 15. Okay, and that's how you find it. So in other words, by the way, so think of it like this. Whereas for the area of a rectangle, where was I? Oh, so whereas the rectangle and the parallelogram, you just do base times height. Since the 2 bases of a trapezoid are different, what they're saying is, hey, add these together first and then divide it by 2 later. So in other words, in a way, you're basically taking the average of the 2 bases. You're saying, okay, since these 2 bases are not equal, right? Unlike the parallelogram, unlike the rectangles, I'm going to add them and then divide it by 2 and then multiply by the height. So again, you're kind of like taking the average of the 2 bases, if that makes sense. And you're saying, okay, on average, how long is the 2 bases? Okay, that's really what it's saying. So, okay, all right, hopefully that helps. So let's talk and let's do some of these questions together. Okay, so I'll start from easy to hard. All right, let's see. Okay, number 1. All right, now what's the shape here? You got to recognize that first. Right, square, right? So how do you find the area of square? Right, take that number, take a side, multiply by itself. So it will be 18 times 18. All right. In the interest of time, all right, I'm gonna use a calculator. That's 324. So 324 unit square miles. Okay. All right. So how do you find the area of a rectangle? By the way, it's always nice to write down the formula too. Okay. So while you're doing this, write down the formula. It should help you. Right. Length times width. Right. 8 times 4. 32 square centimeters. Okay. All right. Number 3. What shape is this? Yeah, parallelogram, right? So that's base times height. Yeah. So that's 11 times 7, 77 millimeters squared. 4. What is that? Yeah, that's a trapezoid. So here's our big formula, right? Base 1 plus base 2 times height, then the whole thing divided by 2. Okay, all right. So let's see, base 1 plus base 2 times the height divided by 2. So let's see, that's 10. 10 times 5 over 2, 50 over 2. What is that? Yep, 25 centimeters squared. Okay, now what kind of shape is this? Yeah, that's a parallelogram, right? So base times height. So base height, right? Which coincidentally happens to be the same number. So base times height. Now let's see, what's base times height? 14 times 14, 196 square feet. All right. Again, another parallelogram. Base times height. Right? What's that? Yep, 96 yards squared. All right, the lights turned off again. Hold on, let me turn the lights back on. Lights are back on. All right, so now that's what? Yeah, that's a trapezoid, right? That's a trapezoid. So base 1, base 2. So base 1 plus base 2 times height divided by 2. So, I don't know if you noticed, but this number here is completely superfluous. All right? Is that the word? Yeah, superfluous, right? Useless. Redundant. All right? Not even redundant, because that just means to repeat something. So, completely unnecessary. It's just there to distract you, and I want to see if you were distracted. So, that's why I put it there. Okay, let's see. Base 1, base 2 times height divided by 2. Okay, so that's 8 plus 5. That's 13 times 4 divided by 2. 13 times 4 is 52. Divided by 2, that's 26. 26 what? Meters squared. Okay, all right, one last one. Now, look at this. Now, again, you know me. I'm always up for these trickeries, right? Like the last one in the triangle video. Right, I turn this upside, no, I wouldn't say upside down, turn it sideways. So if you look upside down, you will realize this is a trapezoid. So again, let's do this. So base 1, right, plus base 2 times height divided by 2. Let's see, that's 80 times 11. Let's see what that is. Notice how I rewrite every step also, okay? Because that's what the cool kids do. So let's see. 880, so 880 divided by 2, that's 440 what? Square feet. Okay? And that's how you do it. All right. Perfect. Now this should have been slightly faster than the last one. What is it? Yeah, 13 minutes, so 14 minutes. Okay, not bad. All right. So that's good. Kept it a little shorter. Let's see if there are questions down there. Nope. Okay. Well, I guess we're done. All right. Thanks for watching, and have a good one.
OMG, that was so good.